So here we have sample A, and if I come in here with my scoop and try to take a look at it, what we see is sample A is really extremely fine powder. I'm trying to press down on it. I hear just a touch of kind of a crinkly, grinding noise. So it is just a little bit gritty, but it's really super fine. In between samples, I'm always going to wipe off my spatula so that I don't contaminate one with another. Here is our sample B. Much different look to it. You can see there's some size, kind of a flaky appearance. If I push down on these, I don't really get that crispy feel that I got for the first one. It's kind of soft and mushes around a bit. Wiping my spatula, sample C. Okay, just by appearance, the grains of this look bigger than A. Definitely gives me that little crispy crunch when I push down on it. You can see a couple of chunks are in here stuck together. Substance D. Just looking at them, D looks awful similar to what C looked like. Definitely has that crisp. You can hear, at least I hope that you can hear. See how when I push on it, it just kind of pops around because the grains seem to grip onto each other and then, pop loose. Okay. Here's substance E. A lot like C and D, isn't it? Maybe slightly finer grains than the last two, but you can hear when I push down. Kind of that crispy sound to it, like there's this pretty brittle stuff underneath. And one more, sample F. Bigger pieces again. Oh. When I push on this, much softer feel to it. It doesn't feel nearly as brittle. A little bit of crunch to it, but it really feels like it kind of mashes down. Okay, much softer feel to it. Alright, so there was initial observation, and I don't know that we learn a lot from the spatula, but I think it's worth something. So, next order of business, I'm going to pause this for just a second and readjust. So I'm really hoping that I've got my camera adjusted at the right spot, because I really can't see both ways, and I wanted to connect this to the other video, so I wasn't able to switch my camera. We're going to try to do a little odor test. Now, you never stick your nose right in the chemical. You hold it and you see if you can notice an odor. That was A. I couldn't detect anything. Now, I don't have the strongest sense of smell in the world. Some people can smell better than others. Some people can hear better than others. Some people can see better than others. My smell is not so good. That sounds bad. My sense of smell is not so good. I don't think I stink, just in case you were concerned. Substance B, I don't detect anything. Substance C, I don't detect anything. Substance D, I do not detect anything. Substance E, nope. Substance F, nothing that I can detect. If anything at all, I think I smell a little bit of soap on my hands. So I wasn't able to detect an odor. Now, as we move forward, it's possible that some odor will pop up in some other parts of this. On to the next step. All right, what you're seeing there is substance A, a little bit of substance A on a watch glass. And I am lighting a burner. And I'm going to adjust this just for a gentle flame. No inner cone. And I'm going to start right now. On my video, that was about 7:02 for time. And I'm going to just lightly heat this sample. I got my flame just barely touching the bottom of the watch glass, and I'm moving it around. So there's about 40 seconds gone, and I am not seeing any change. I'll have to tighten my camera stand after this one. Alright, there's a minute with no change. So while this is not a really super duper exact test, it tells you that it doesn't melt easily. So I'm going to take substance A away very carefully because I don't want to drop it and break it. Best bet is usually to not move hot things, but we're in a time constraint. And here is substance B. And I'm going to start about 8:45 on our video. And I'm just touching it. You see some condensation, fog on the watch glass that cooked off. Oh, I'm seeing change. Alright, that was from 8:45 and heating it about the same way by within 15 seconds. We had a lot of melting going on. It looks like we're pretty much a liquid now. Okay, so about 15 seconds is all it took. I'm going to try to very carefully move this one out of the way. And we're going on to substance C. Substance C, and I'm going to start at 9:35. There's about 20 seconds. there's about 30 seconds, and I don't know if you can see, there is some liquid forming around the edge. Definitely some melting taking place. Didn't seem to melt as quick as B, but substance C is melting. I will also certify, do you see that it's turning color a little bit? It's got a little bit of a yellowy, browny, kind of gold color to it, and it has an odor now. And if I had to put a name to the odor, I'd say it smells a little bit like burned sugar, like a burned marshmallow. All right, I'm going to set substance C out of the way and put substance D in place. Camera's slipping again. Substance D. I forgot to look at my time, but we'll say about 11:40 on the video. And I think I'm seeing some change. You see that? It's it got wet and it's kind of bubbling. There seems to have been like it's changed its appearance, changed its texture. But you notice how it's bubbling in the middle, but the outside doesn't seem to be liquid anymore? So we still have lots of solid here. I'm still heating it. So there was definitely a change. It's kind of puffed up in the middle. You can see it's still puffing a bit. So we got a liquid, and yet now we're back to a solid. So I would say something other than melting just happened there, because if we melted it, it should have just turned to a liquid and been done. All right. That was substance D. Move this one out of the way. Substance E. Starting at 13:15 on the time. Over 30 seconds now. No change that I can tell. Well, there was a minute with no change that I could tell. So obviously it didn't melt very easily. So I'm going to move substance E out of the way and get ready for our last one. Okay. Here is substance F. And I'll start at 1450. Oh, and it's less than 15 seconds, and I could see some obvious melting on that one. I took the heat away, but there's still enough heat there that it's continuing to melt. The only one that I really noticed any extra odor on was C. The only thing I'm smelling right now is a little bit of extra gas coming from the burner. Not from Mr. Rupplinger, from the burner. Okay, I'm going to reset my camera. Okay, this might be a bit tricky. I have substance A, just a tiny little bit in a test tube. And what I'm going to do is add, if I can get my aim worked out here, I'm going to add a little bit of water. Ooh, that's more than I even thought I was going to do. And put a stopper on. I'm just going to shake this up. I'd like to see if any of substance A is still there. And it's really hard to tell on the camera, isn't it? Well, we're going to have to do a combination of camera and what I'm going to tell you. And I would say substance A seems to have dissolved in that water. I think the only thing I'm seeing on the bottom there now is just reflection. Alright, we're going to try the same thing with substance B. So if I can find a camera. Try to put in about the same amount as I did with the last one. Something we can notice is substance B seems to float. Okay, I put a stopper in. Give it a good shake. And we still have a whole bunch of substance B floating on top of our sample. So substance B did not seem to dissolve. Substance C. Squirt of water, add the stopper. Looks like a little bit still in there. I'm going to try give it one more good shake to see if that changes things. It looked to me like there was less, but not gone yet. Okay, I think I have a better view of it here with my eyes than on the camera. And I think that looks clear through. I don't see any solid bits anymore. So it looks like substance C dissolved. Substance D. Honestly, I didn't even shake it yet, and I think it might be almost gone. But we'll give her a shake, just like the other ones. Hard part's really getting it where I can see and the camera can see at the same time. But I think that has turned totally transparent. I don't see any solid pieces anymore. So it looks like substance D was soluble. Let's try E. Add a stopper. I think that looks like it's all clear. Some bubbles on the side of the test tube, but that's about it. So it looks like substance E dissolved. One more. Substance F. Substance F looks like it's floating to the top of the tube, like B did before. Might tell us something about density. And shake it up, see if it dissolves. Okay, good vigorous shaking, and there's still a whole bunch of substance F floating there on top of the tube. So F does not look like it dissolved. Okay. So, for the last part here, I'm going to have to just set my camera one more time. Okay, what I have in front of you is a multimeter. It's used for studying electric circuits and things like that. And right now I have it set to measure resistance. And resistance is kind of the opposite of conductance. Okay? So right now I have two electrodes. I'm going to move a couple things in front of me so I don't spill. I have two electrodes, if I can show them to you, and they're not touching. And when they're not touching, air is a really good resistor. In other words, air is not a good conductor. And so this needle is pointed all the way over here at something like infinity. And if I touch these two electrodes together, you see the needle goes basically all the way to the other side, which is a great conductor. So if we look at, how about this scale right in here, this scale goes from 0 to 250. So we're going to say that 0 is not a good conductor, and 250 is a really good conductor. Okay, that's my electrodes. So now what I'm going to do is dip these electrodes into our solutions. I'm going to start out just with a control solution to show you. Here's just a little bit of distilled water. Okay, so you can't see this and the meter at the same time, but I'm just going to take my two electrodes and put it in there. Okay, and I'm a little bit worried on this because that moved, my needle moved way too much. Let me show you. So when I put those in there, this is what my needle did. So on that scale, it looks like it went to about 140, between 140 and 145. I'm nervous about that. I don't think distilled water should have done that. I think distilled water should have stayed really low. But that's the water I used. I wonder if a student has refilled the bottle on me at some point. But I guess we're going to try to live with that. So I'm going to take sample A. Remember, distilled water was 140. Let's try sample A. Looks pretty much in the same ballpark as distilled water. 135. Okay, now I'm going to try sample B. Again, pretty much like the distilled water. The suspicious distilled water. I'm going to try sample C. pretty much like the distilled water. About 130. I'm going to try sample D. Well, 150, it went a little higher than the others. Not much different. Sample E. Sample E went quite a bit further. 180 on that scale. Sample F. $145. This is concerning me a little bit. I don't think that was the best test. I want to go back to D one more time. Oh, okay. So D is going up higher. All right. So what I'm seeing is that D and E both seem to conduct better than some of the other ones. I'm feeling a little bit better about that. I'd like to check A again. Nope, A is looking kind of like it did before. I'm going to check C. That way I'm double checking all the ones that dissolved. Yeah, C is not going very good either. Okay. So, we learned a little bit there. And we learned that D and E were better conductors. And you can think about what that means. I'm just going to take a glance at the procedure. I think we've done all the tests that are on the procedure. It is not at all ideal, but I want you to take this information and write up a lab report where then in your analysis and conclusion, you're going to try to say substance A. I think substance A is, and you say ionic or covalent, and then you give me your reasons. And then you go to substance B. They should be well thought out reasons. So long as you have well thought out reasons, I won't be marking it right or wrong. I'll be grading your lab report. Now, if you don't give me any reasons, then we have some issues. All right? So, we'll see what we can do with this. We'll see what you guys come up with. And hopefully we get some decent results. All right. Take care.